Hey there, everyone. Welcome back. This is Systems of Equations. Let's just dive right in and look at deep into what's going on here. There's a bit of material to cover. Because of the video last time, we can skip through a little bit of it here and there. Please make sure that if you're missing anything, just let me know, and I'll be happy to help as best I can. So the goal in systems of equations, the end goal of all the problems that we do, or at least the ultimate goal. Sometimes the problems don't actually get to that ultimate goal, but the final objective is to find a value for x and y, or your two variables, whatever they are, that solves both equations at the same time. So they give you two equations and they want you to solve both of them at the same time. Let's just remind ourselves of what a solution is. A solution in the realm of equations, that realm that uses numbers and all those things, not the realm of graphs where you can see all the pictures and visuals and stuff. A solution is a value for x and a value for y that you can put in an equation and make both sides of the equation equal each other. Because when both sides equal each other, you get things like 4 equals 4 and 7 equals 7, and all that's good and true. And remember that the point of math is to find truth, to find things that are true. Okay, so in our case, to bring this out into a deeper example, let's say we had an equation that said like 6 equals 2x. You could look at this. Some people, you might be able to look at this and immediately know what the answer is. We can divide both sides by 2 and get 3 equals x. So we know the answer to this equation, the solution to this equation in terms of x is 3. The reason why 3 is the solution, the reason that the point of it being the solution is that if I was to plug 3 back into the equation, I would get 6 equals 2 times 3, which gives 6 equals 6. I get a true statement. That's the reason why a solution is a solution, because it creates a true statement. It creates truth. And that's what we're trying to do here. So what we're going to be given is two equations, such as something like 6 equals 2x plus y, and 3 equals 7x minus 4y. And we need to find a way to make these, to find a value for x and y that makes both sides of both equations true at the same time. That's what we're trying to do here. Okay, so let's go back into the realm of equations. Now, solving systems of equations, there's two good ways of doing this, of solving an equation like that. Substitution is one of them, and elimination is the other. You can use either one of them, and either one of them will get you to the answer every time, but one of them is always going to be a lot simpler than the other. Well, usually, almost always, is going to be a lot simpler than the other. Okay, so, but again, if you're just blanking on how to use one of them, just use the other one. The other one will get you there, especially with the problems that we do. But to really break down how these two things work without instead of just giving you this and walking through this wall of text, let's look at one of the problems, and I'll try to explain it through that. It says find the solution to this system of equations. It also gives us the option to use an interactive graph to do it, and we'll look at the graph soon. But let's start with the actual numbers. So we've got negative 2x plus 2y equals negative 4. So we've got negative 2x, negative, oh, that's the eraser. Negative 2x plus 2y equals negative 4? Equals negative 4. And 3x plus 3y equals negative 18. Okay, negative 4, 3x plus 3y equals negative 18. Okay, what we're going to do is I'm going to walk through how to do each process, and then we're going to do both of them, and we're just going to see all the different ways that we can solve this problem. Okay, let me just check to make sure one more time things are right, because writing down the problem is one of the worst mistakes you can make in math, because that means you do all this really hard work and you can do everything right, but then you'll get the answer wrong. So it's good for me to check. Say 3x plus 3y equals negative 18. Yep, okay, that's the same thing. Those are the same numbers. Okay. The first way, the two methods, substitution and elimination, and both methods, your end goal is to end up with an equation that only has one variable. Because if you have an equation with one variable, like 3x plus 7x equals 10 or something like that, you can solve that. And you may already know how to solve a problem like this. You get 3x plus 7x, that equals 10x equals 10. Divide both sides by 10, you get x equals 1. So you can do something like that. That's just something I just made up on the spot. That's not actually a problem. But the point is, if we can get to a problem that just has one variable, such as like x or y, then we can solve things. We can figure out, we can get progress. The problem with these two equations, is they have two variables involved. And so the question is like, well, how do we work with two variables to solve? We can't solve either one of these variables alone because there's two of them. So there's two ways of going about to making an equation that has one variable. One of the ones is called substitution. And substitution, kind of the idea behind it is, it says, well, we really kind of noticed that we can't solve a variable discretely. We can't just say x equals 7 or something like that. We can't get to that with one of the equations. But let's see how far we can get with it. We'll get x equals something, and we'll use that something and work from there. So we'll just pick one of them. Let's say I just picked the first one, minus 2x plus 2y equals -4. Let's say I said, I just want to solve for x. So the first part of it is solve for one variable on one side of it, on one equation. And that's what we're just going to do. We're going to just solve for x. We know it's not going to help us. It's not going to give us anything that's super helpful. It's not going to give us the answer or part of the answer. But we're going to go with it as far as we can. So -x minus 2x plus 2y equals -4. And let's just write that down at the top. This is substitution. Substitution. So you can remember this is the way we're solving it. Okay, now minus 2x plus 2y equals -4. We're going to solve for x. And the way to solve for x, we do that with the same with every other problem that we do. We start with the things that are furthest from x. We want to get x all by itself on that side of the equal sign. So we're going to start with the things that are furthest from x on that side of the equal sign, and then look at things that are closest to x. The things that are furthest from x is this plus 2y. So to get rid of that, we do the opposite of what the plus 2y is doing. Let's see, we got a plus 2y on the x. So if I want to get rid of the 2y, the plus 2y, I'll do the opposite of what it's doing. And what is it doing right now? Right now it's adding. We're adding a 2y. So to get rid of it, we'll subtract a 2y. But what I do to one side, I have to do the other. So we'll subtract 2y from both sides. So we get minus 2x. Let's see, plus 2y minus 2y. That cancels out. So we can just cancel that out. Equals -4 minus 2y. Okay, good. Good so far. Good so far. The next step in solving a variable is let's just point out, this is all step 1. Okay. The next step in solving the variable is the thing that's right next to x. There's only one thing left. It's a -2, and there's an imaginary multiplication sign. So we're going to get rid of that imaginary multiplication sign by doing the opposite of what it's doing. So it's a -2 times x. And we want to get rid of that time, that -2 times something. And in order to get rid of the something that's happening to it, we have to do the opposite of what it's doing. If it's multiplying, we need to divide. So we'll divide both sides by -2. Divide that by -2, divide that by -2. Okay, these cancel out. -2 divided by -2 is just 1, or just cancels out. So that gives us x equals -4 minus 2y over -2 or -2. Great. So that was the first step. Not really helpful so much. It just gives us something. We just solve for x. But we can still work from here. This is the first step in the process. The second step of the process is what the whole substitution thing is about. It says, let's plug that answer. We're going to substitute it into the second equation. And I'm going to silence my phone because the scammers like to call me all the time. All right. So we're going to substitute that in the second equation. The second equation is 3x. Let's start this next step. 3x plus 3y equals -18. That's the second equation, or that's the other equation we're working with. So to make this work out, we need to plug this answer that we got in for x. So, and this is what we said, when we get to an equal sign, what an equal sign means is that both sides of the, on the side, things that are on both sides of the equal sign are the exact same thing. They mean the same thing, they are the same thing, they're the same thing. So X literally is. It's not like it just represents something. X is -4 minus 2y divided by 2. That's what X is. So when I say that we have 3 times X plus 3y equals -18, we can say, instead of saying X, we can say what X is. We can say it's 3 times, instead of X, we'll say 3 times -4 minus 2y all over minus 2. Now you might notice that I put parentheses in here. That's because this is a 3 times an x, and I want to make sure that 3 is being times or multiplied by the whole x, the whole -4 minus 2y divided by -2, not just one part of it. And so the parentheses help remind me to do that. So 3 times -4 minus 2y over -2 plus 3y equals -18. Well, hey, look at that. We've got an equation that has just y. It has just y in it. That's all it has. And so we can work from here. We can work and just solve with just y. Because if it's something that has just y, it might take us a few steps. It might take us a good long while. But we will eventually get the answer. So this is the end of step 2 for us. Okay. So that brings us down to the next section down here. So once you've done the substitution, we can go down and actually do the final 3 steps and work from there of this problem. And we're going to go ahead and we're going to do elimination next, and I'll show you what that looks like. Let's start with this though. So, okay, we've got this. Let's simplify this a bit. This is a lot going on here. We can simplify it a good bit before we do anything fancy. Or how about this? Let's say there's a 3 on, there's a 3 times the first x and a 3 times the y, or 3 times that -4 minus 2y over -2, and a 3 times the y, that equals 18. Maybe we can just get rid of that 3 all at once. Let's see, it's 3 times all these things. So we're going to do the opposite of what it's doing right now. We're going to divide by 3. We'll divide this. Oops, that was my register still on. I'm going to divide all of that. So the next 3 steps, let's start with this. 3 times -4 minus 2y over -2 plus 3y equals -18. Now here's a common misconception. This might be important to write down, remember, or do something with, because we often forget this. And I feel like it's been presented in a very unhelpful way for many of us when we were going through elementary school. People say you got to do the same thing on both sides of the equation. I've said that we need to do the same thing on both sides of the equation. Whenever you do something, you just got to do to both sides of the equation, you're good. Now that's helpful when you're like adding and subtracting on both sides, but when you're multiplying and dividing, it's not just happening to both sides of the equation. It is happening to both sides of the equation. Maybe a more helpful way of understanding it is that it's happening to every single term in the equation, every single individual unit in the equation. Let's look at what those terms, those units are in this equation. We've got 1 unit here, this 3 times x, which is all of this stuff. We've got a unit here, 3 times y, and we get the -18, that third unit. It's like they're their own things. The things that separate a term, an entire term, a whole unit, will always be a plus sign or a minus sign. Those are the things that separate terms. Okay, so if I want to simplify this down a bit, one of the things I can do is I can divide both sides. I can get rid of the 3's on the left side by dividing the whole equation by 3. So I'll divide this left side by 3 and the right side by 3. And what that means is I'm going to divide, in other words, what I'm doing is I'm dividing every term by 3. You can think about it this way. I've got 3 times -4 minus 2y over -2. All of that is being divided by 3. I've got plus 3y divided by 3. And I've got a minus 18 divided by 3. Because they're all the same. I'm dividing every term by number. You can multiply every term and divide every term by number. Another way to think about it is that this is like, I want to divide both sides of the equation by 3. On this left side, I've got a giant fraction, and I can split up that fraction into two smaller fractions. One fraction's this 3 and all this business, and the other fraction's just 3y divided by 3. Okay, so that's what we have here. If I do that, that helps us significantly. You can see the 3's in this left side cancel, the 3's in this y cancel. And let's see, -18 divided by 3, that is -18 divided by 3, that's -6. So we'll write -6 on the right, and because that's -6. And that leaves us, let's see, -4 minus 2y over -2 plus y equals -6. Okay, let's see if we can further combine this together. We've got remember in our equations, one of the first steps we want to do in an equation is get all the y's on one side of the equation. They're all on one side of the equation. Now we need to get them all together. We need to unify them. So we need to combine them somehow. Unfortunately, one's in a fraction and one's not. So what we're going to do is we're going to try to get this y, the second y down here, into the fraction somehow. Here's what we can do. Remember how we can multiply. We can multiply anything by 1, and 1 can come in many forms, like 1 over 1 or 4 over 4 or 7 over 7. We can do that with this y here. We can multiply this y by -2. We can give it the common denominator with the fraction by multiplying by -2 over -2 times y over 1 times y, or y over 1, it's the same thing, equals -6. On this side, we got -4 minus 2y over -2. Now, why did I choose -2 over -2? I chose it because it creates a common denominator. That if the denominator isn't the same, then we can add terms together. We can add this top section together if the denominator is the same on both sides. So we're going to have this to help us give that common denominator that we want. Okay, so -2 times y is -2y over -2. On the side, we still have the -4 minus 2y over -2. This gives us -6, and we need to add them together. So we get -4 minus 2y minus 2y. That is -4y. We can say -4 minus 2y minus 2y. All of that over -2, which is -6. Minus 2y, minus 2y comes together to make -4y. Minus 4y. Okay, and then the next step we can do is we can multiply. We can get rid of that. Now we've got, okay, so we got that done. We've gotten the y's all together. So the next thing we need to do is to get y all by itself. And we're going to start by getting rid of the things that are furthest away from y. The furthest thing away from y right now, that's on this side of the equation, so we care about the first thing away from y on the side of the equation, is this -2 at the bottom. So we're going to get rid of that. Okay, so this whole thing is being divided by -2. So to get it back together, what we'll do, or to get rid of the -2, we're going to do the opposite of what's doing. We're going to multiply by -2. Multiply this side by -2, multiply that side by -2. We'll get, these cancel out. So we get -4 minus 4y equals -6 times a -2. That gives us 12. It's -6 times -2, so negative times negative is a positive, and 6 times 2 is 12, so 12. And then, okay, the next thing that's furthest away from the y is at -4. -4 is being subtracted. It's at -4. So we'll do the opposite of subtraction. We will add. So we'll do 4 plus and plus 4 on both sides. So the 4 plus -4, that cancels out. So we get -4y. Oops, let's just let's make it a little clearer. Okay, so the reason why The problem is that there's this minus. The reason why we use a 4 plus, or we said we added 4 to both sides, again, is because this minus next to the 4. It's not because it's being subtracted. There's this minus 4y. The term itself is minus 4. So we're subtracting 4. The 4 is being subtracted, so we're going to add to get rid of it. Hope it makes sense. If it doesn't, just let me know. I can help you more. I can walk you through it more and more clearly. So you got a minus 4y equals 12 plus 4, which is 16. And we're almost done. So with this part, so we need to get rid of that minus 4, which is being multiplied by y. That imaginary multiplication. So we're going to do the opposite of that, which is division. So we're going to divide both sides by minus 4. Minus 4, minus 4. Or in other words, we're dividing every term by minus 4. This minus 4y and the 16, we're dividing every term by minus 4. So minus 4 is canceled out. 16 divided by minus 4, that gives us minus 4. Because a positive times a negative is a negative, so it gives us a negative. And 16 divided by 4 is 4. So that gives us 4. So y equals minus 4. There it is. So that is the way to find the y value through substitution. That was that first step. So we solved that equation. And the second step is to plug that answer. The second step is to plug that answer into either of the original equations. It doesn't matter which original equation we put it in. We're going to plug it into one of those original equations. And then we're going to solve that second equation. So second step, let's pick an equation. We'll pick the first one, because why not? So second step, we have minus 2x. Is that plus 2y? Yeah, plus 2y equals minus 4. Okay, now we know that y equals negative 4. Y is the same thing as negative 4. So the second step says we're going to plug in, we're going to substitute negative 4 for y. So this will be minus 2x plus 2 times negative 4 equals negative 4. Which gives us minus 2x minus, let's see, negative 4 times 2. That's positive and negative, so it's minus 8 equals negative 4. All right, add 8 to both sides. I'll just try that quickly. So because the first thing we need to get solved for x, and the furthest thing away from x on the side of the equation is the 8, the minus 8. And so it's a minus, so we're going to do the opposite of minus. We're going to add plus. We're going to add 8 to both sides. Plus 8, plus 8. So it gives us minus 2x equals, see, minus 4 plus 8 will be plus 4. And then to divide both sides, because 2 times x is a negative 2 times x is there, we're going to do the opposite of multiplication. We're going to divide by negative 2, divide by negative 2. So that gives us, that gives us x equals, let's see, 4 divided by negative 2 would be negative 2. So that is the second part of our answer. So our final answer, solution to this, is negative 2, negative 4. So that is the solution using substitution. You can see in this instance, substitution took a very long time. So this was not the advantageous one to use, but it was a possible route. Let's look at the same method using elimination and see how elimination helps. So that's substitution. Elimination, this is, let's make sure I have enough space in there. Right side, yep. Okay, elimination takes a different route. Okay, let's rewrite the problems up first. Minus 2x plus 2y equals minus 4. 3x plus 3y equals minus 18. And you might see that elimination will be a little bit easier in the long run. Hopefully, in this particular problem, hopefully. So elimination says, well, it really capitalizes on the nature of the equal sign. It says if something is on one side of the equation and on the other side of the equation, they're both equal. They're the same thing, and so they mean the same thing, so they're used interchangeably. And so when we add something to both sides of the equation, we can add something that's on either side of the equal sign. Now, right now, that probably sounds like a lot of gibberish. So let's walk through what that actually means. The first step of elimination is to multiply or divide all terms on one equation so that one variable equals the variable in the other equation. So example, 3y in the first equation, 3y in the second. So here's what it's saying. It's saying we've got like a negative 2x and a 3x. We've got 2y and a 3y. We want to multiply this first equation up here, by something. The first step is let's multiply it by something and multiply the second equation by something. So that when either the x's have the same number, it's like 3x and 3x, or 6x and 6x, or the y's equal the same number, say 5y and 5y, or 10y and 10y, or negative 10y and negative 10y. Something that they are all equal. So let's think about this. What is the least common multiple of negative 2x and 3x? Let's try x. And if we find the least common multiple, well, if I multiplied, let's see, if I multiplied negative 2x by negative 3, and I multiplied 3 by 2, I would get 6 in both cases. So that's what I'll do. If I multiply, let's look at this. If I multiply this, if I could not use eraser for a second, if I multiply, let's use a slightly different color so you can kind of see what's going on here. If I take a negative 3 and multiply on the top and a 2 on the bottom, I'm going to multiply the negative 3 times negative 2x plus 2y equals negative 4, and I multiplied the 2 by the 3x plus 3y equals negative 18. If I multiply that on both sides of the equation, because remember we were doing one side of the equation, doing the other, so negative 3 times negative 3 and 2 times 2, then I'll get 6x on both equations, and that's the goal. So I want to have the same number for either x or for y in both equations. And you can kind of see if you want to go back to what we were talking about before. This is when I work this out, it's kind of like I'm multiplying negative 3 by every term in the equation. I'm multiplying negative 3 by the negative 2x, I'm multiplying by negative 3 times the 2y, and I'm multiplying negative 3 by the minus 4. Every single term is going to get multiplied by negative 3. So I'll get 6x, because negative 3 times 2x is 6x, and then 3 times negative 2y is minus 6y, equals, let's see, 4 times negative 3 is 12, because negative times a negative is positive. So again, I took every single term, the negative 2x, 2y, and minus 4, and I multiplied each term by negative 3. Is another way of thinking about that. And the bottom, we'll do the same. 3x times 2 is 6x. 3y times 2 is 6y. That's a plus 6y. And the negative 18 times 2 would be a negative 36. Okay, here's what we're going to do. That was step 1. We've done step 1. That's all we had to do for elimination. So that was step 1. Step 2 is line up the equations. So the x's, the y's, the equal signs, the constants are above each other. And that just kind of just happened for us. It's pretty convenient. The x's are right above each other. The x's are right above each other. The y's are right above each other. The equal signs are right above each other. The numbers are right above each other. They're all kind of lined up. And you want to have that lined up view. If you can do that, then this all just plays out really nicely. In just a second, we'll see what happens. And well, once you've lined up the equations, so that's already been done for us. It's already just happened to be that way. The next step is to subtract the bottom equation from the top. So we take everything and subtract everything. Okay, so we're going to subtract the 6x from the 6x. We're going to subtract 6y from negative 6y. And we're going to subtract a negative 36 from 12. And here's what we're doing. And here's exactly what this means. It's kind of like this. If you've kind of been familiar with elimination a little bit more, here's why this works. We're taking the 6y and the minus 6y, and we're subtracting 6x and minus 6y, and we're subtracting 6x plus 6y. And on this right side, we're taking 12 and we're subtracting 36. So subtracting 36. Oh, I wish I had more space. Oh, I have more space. Here we go. On the other side, I'm taking the 12 and I'm subtracting 36. And at first this looks weird. Like what gives you the authority to subtract it from both sides? Subtract these two things from both sides. But then we see that 6x plus 6y equals negative 36. It's kind of like I'm subtracting a negative 36. Oh, sorry, I'm subtracting a negative 36. It's kind of like I'm subtracting 36 from both sides. I'm subtracting a negative 36 from both sides. Negative 36. It's almost as if I'm subtracting a negative 36 on both sides, but I know that negative 36 equals 6x plus 6y. So it kind of works out in the end. So instead of subtracting negative 36 on the left side, I'm going to subtract a 6x plus 6y because that's what negative 36 is. It literally is 6x plus 6y in this equation, in this scenario. So we can kind of do the subtraction thing. And then when you distribute the negative, you get let's see. So this becomes minus 6x plus 6y, which is, in other words, minus 6x minus 6y, which is exactly what we're doing in this front side over here. Okay, so that's really what we're doing. Let me just partition that off because that's not really relevant to the problem. I'm going to do a better partition. Okay. So 6x minus 6x, that's just 0. 6x, or minus 6y, minus a positive 6y, that is, let's see, a positive and a negative, that makes a negative. So that's kind of saying like minus 6y minus 6y. So that gives us minus 12y. And that 12 minus a negative 36, that gives us, let's see, a minus and a negative. That comes together to become positive. So that's like a 12 plus 36 is kind of what that is, which gives us a conveniently a 48. Okay, so we got 0 minus 12y equals 48, which means, a 0 is just nothing, so we can just get rid of that. That's just minus 12y equals 48, and we need to solve for y. So let's see. We did step 2. We learned the equations and subtracted the equation from the top. So this is step 2, was already finished. And step 3 is that subtraction. And so now we've got 0 minus 12y equals 48. Now we're just moving on to the next step. This step over here, this step is in sync with this step. And you might be interested to notice that we're going to get the same answer for this. We're going to, if you divide both sides by negative 12, because it's negative 12 times y, we do the opposite and divide by negative 12. Divide by negative 12. See the negative 12s cancel out. So we get y equals, let's see, 48 divided by negative 12. That's a positive divided by a negative, and a positive and a negative makes a negative. And 48 divided by 12, if you know your 12 times tables, that is 4. So y equals negative 4. And look at that. We saved all this time and all this effort to find y equals negative 4 because it chose the right method. The more you do these kinds of problems, the more you can kind of just tell which one is the best method, which way, when things can line up better that way. Usually the substitution is better when it starts off with something like 1 times x. So if you had like 3x plus, is an example, 3x plus 4y equals 7, and then x minus 2y equals 16. If there's any variable that's just all alone, like just x minus 2y, that can often be an indicator that substitution will be a much faster route, but it doesn't always. Especially if there's a really good method, a really good way to do an elimination. So if you can find a really easy way to do elimination, then just go for that, and that'll get you the answer. Okay, so that's elimination. We did y equals negative 4, and then we can work from there. Once you find that y equals negative 4, it'll look exactly the same as all of this down here. I wonder if I can just copy and paste it. And I don't think I can copy, but I can move all of this straight up here, straight up to the top, and that would work. I can't copy it though, so unfortunately, because of the limitations of an iPad, but that's all right. Or can I? No, I can't copy it. There we go. There we go. So I'm gonna copy that, and I'm just gonna paste that right in over here, and that'll give us done. If I can paste, maybe I can't paste. Oh, that's too bad. But you know, that's how we'd solve that problem. And I think that'll get us where we need to go. All right. So we'll move. I think you can kind of get the idea of what to do the rest from here. Eventually, the answer is going to be -2, -4. That's going to be -2, -4. Once you plug everything back in, that'll be our answer. Yeah, I should just do the problem just to make it very clear. So I don't mean to waste your time, but I don't want you to think that I don't want to show any misjumps. So -2x plus 2y equals -4. You know what, for this problem, let's try the other problem. Let's just try the other equation. Just show you it does the same thing. If we do 3x plus 3y equals -18 equals -18. This is step 2. We're going to substitute in. It doesn't matter which equation we chose. We just chose the equation this time. I'll plug in -4 for y. So we get 3x plus 3 times -4 equals -18. And we'll get 3x minus 12 equals -18. Minus 12 equals -18. And you add 12 to both sides, plus 12. And we get 3x equals negative, let's see, -18 minus plus 12. That's 18 minus 12, and then that's a negative answer. So that gives us -6. And so divide both sides by 3. Divide both sides by 3. That gives us x equals -2, and that's our answer. So our final point is -2 and -4, which is the same answer as down below. Cool. So that's the answer. That's how we solve those problems with elimination. All right. Now, one last thing to mention before we move on, or maybe 2 last things, is the realm of graphs. Graphs are a little bit different. The way a graph works, I wish you could see the graphing paper that's on here, but it doesn't really show up well in the video for some reason. In the realm of graphs, the solution is the point where both lines intersect. Because remember, if you remember from the last video, remember that in the last video we talked about, if you watched it, this is an equation. The equation of a line, whatever it is not really a line at all. It's not really, it's kind of a lie. It's just a bunch of points that are all really, really close together. And together they make a line. They make what looks like a line, but it's not a line. It just looks like a line. And so if you've got two of these things, these 2 sets of points, where each point is a solution to the equation that's trying to graph, and every single point is a solution to the equation it's trying to graph, then a point that looks like that kind of goes in these 2 imaginary lines that aren't lines, but just points. If there's a point that goes for both of those, then it's going to solve both of those. So if you just find the point where these 2 quote-unquote lines intersect, then you will have the answer. You'll have the exact answer. So in the equation, in the case of what we did with substitution and elimination, if we graph those 2 equations, these 2 equations somehow, and well, actually, yeah, let's graph these 2 equations just to see what it looks like. I'll give us some more space so we can kind of see what's going on here. So you got 2x plus 2y equals -4. So this is going to be graph. Let's see, -2x plus 2y equals -4. -2x plus 2y equals -4. And then on the other side, we have 3x plus 3y equals -18. And in this section, we're going to actually graph both of these equations and see what it looks like. And to see a better version of this, that's okay. To see a better example of this, well, I think I'll just use a different color, so you can make it very, very clear what's going on. Maybe we'll see some orange. So 3x plus 3y equals -18 will be that one. 3x plus 3y equals -18. And for the first one, we'll use that in, let's say, green. So that's -2x plus 2y equals -4. Okay, that's gonna look pretty funky. But let's go ahead and try to graph these equations, these lines. Let's start with the first one. To graph this, usually it's best to just put in slope-intercept form, unless you're really fancy and you like point-slope form. And you can do that if you like it. And actually, for many people, that might actually be even faster. But But if you're not comfortable with point slope form, let's just work with slope intercept. Slope intercept is y equals, let's actually use the proper color, y equals mx plus b. That is the slope intercept form. So if I want to turn this, I'm going to turn both these equations to slope intercept form so I can graph them well. So minus 2x plus 2y equals -4. Let's see. Let's turn that into slope intercept form. I want to get y all by itself. Another way of thinking of slope intercept form is you're solving for y. That's just solving for y. That's essentially all slope intercept form is, if you want to think about it in that way. Okay, so we're going to solve for y. We're going to get rid of that 2x on the left side, and it's being subtracted. It's a minus 2x. So in order to we need to do the opposite of what it's doing. It's doing a minus 2x, so we're going to add 2x to get rid of it. So plus 2x plus 2x. So we get 2y equals minus 4 plus 2x. And we're given, okay, so we've got that. Then we need to get rid of that 2. So we'll divide both sides by 2. So this gets divided by 2. This gets divided by 2. We get y equals, let's see, minus 4 plus 2x over 2. That's not quite in slope intercept form, but we're getting closer. We need y equals something times x plus something. Let's split up this equation, this fraction, see how that helps. We get y equals -4 over 2 plus 2x over 2. Let's see, these 2's cancel out, so that makes it just x. So that gives us equals -4 over 2. Ooh, -4 over 2, that's just, let's see, that's a negative times a negative divided by a positive. Negative and a positive makes a negative. And then 4 divided by 2 is just 2. So -2 plus x. So y equals -2 plus x. Or if we were to switch that around a little bit, so it makes it so we can write it in proper mx plus b form, y equals x minus, excuse me, a minus 2. So x minus 2. Okay, now I switch them around because we want to have that x first. That x needs to happen first. First the x and then the number. All right, so y equals, that's mx plus b for that equation. Let's look at the slope intercept of the other equation. We've got 3x plus 3y equals -18. Okay, now we need to graph this. We need to put this in the proper form. We'll get rid of the 3x to solve for y. So right now it's being added. We're adding 3x, so we're going to get rid of the 3x by subtracting. Minus 3x minus 3x. So it gives us 3y equals -18 minus 3x. Okay, then we need to get rid of that 3 at 3 times, so we divide by 3. Divide by 3. So it gives us y. The 3's cancel out to make 1. This cancel out. So it gives us y equals, what is that? That is -18 minus 3x divided by 3. We'll split that up into 2 fractions again. We'll make that -18 over 3 minus 3x over 3. Okay, so let's see. So y equals, let's see, -18 divided by 3. That would be, let's see, minus times a positive, minus times divided by a positive, minus and a positive make a negative, or a minus. 18 divided by 3 is 6. And then minus 3x divided by 3. 3 divided by 3 is just 1. So minus 1x, or just minus x. Excuse me, that's just minus x. Minus x. Okay. So that gives us, we need to write this in the proper form where x comes first. So we'll write y equals minus x minus 6. Okay, cool. We've got our 2 equations. Now we should graph them. Actually put them on that graph. So go ahead and make a graph here. Make graph. And when you look at if you're referencing the 1 node right now, when this is completed, you'll actually be able to see the tick marks. 2, 3, 4, like in full grid lines. So it'll be much easier to work with. So, but this is, if I want to graph the line, remember how to graph a slope intercept? We graph the slope intercept by first graphing the intercept, and then we do the rise over run. Okay, so we start with the green one. The green one starts at -2 because -2 is the y-intercept, and then we have a rise of a run of, let's see, that's an imaginary 1 times the x. So rise of run of 1. So every time we rise 1, we run 1. Or in other words, every time we go over 1, we rise 1. So rise 1, run 1, rise 1, run 1. And we'll keep plotting those. We can keep plotting those as much as we want to. We can plot the points in between. And normally when you graph this, you graph a line. So we'll graph a pretty decent line through there, just like that. Now remember, this isn't a line. This is just the combination of all the points. Okay. Now the next step is to graph y equals negative x minus 6. We're going to go ahead and work with the, well, let's see, we'll start with the y-intercept. So minus 6, 1, 2, 3, 4, 5, 6. All right. And then we have a minus 1 for the slope. Minus 1 times x. So that means we're going to, every time we go over 1, we're going to fall 1. We're going to go rise a negative 1. So we'll move 1, fall 1, move 1, fall 1. We'll graph the points in the middle. We can put them together, and that creates what looks like, but isn't, a line. And you can see we have that nice intersection right down that quadrant down there, that third quadrant. So that's quadrant number 3. If we find that, that looks like negative, let's see if that looks like the coordinate. Let's see, negative 1, negative 2, negative 1, 2, 3, 4. So this gives us the points negative 2, negative 4. And that's the point where they intersect. That's the one point of all these points. That's the green points. That's the green points that solves the green equation. That's the orange point that solves the orange equation, and does both of them at the same time. So this would be the solution of both equations, negative 2, negative 4. Okay, and that's how we solve that using graphs. Okay, cool. One more thing. Sometimes there's not one solution. Sometimes we get really weird cases that aren't just the way they're supposed to be. Sometimes when you're trying to, after you do a substitution or elimination, you get something really strange. I could get 4 equals 4 or 7 equals 7. And that's, instead of having an equation like this, like this right down here, like this down here, you'd get something really strange like 4 equals 4 or 7 equals 7. And what that means is that it doesn't matter what y is, it doesn't matter what x is. You're always going to have a solution. There's a bunch of solutions, even infinitely many solutions. If it doesn't equal each other, if it's like 2 equals 3 or 7 equals 5, then in this sort of answer, or maybe another way to find it is right down here when you do the elimination. If instead of getting minus 12y equals 48, you get like 3 equals 7. If you get something like that, then you know on top of there that that has no solution. It doesn't matter what you put in there for x, it doesn't matter what you put in for y. There's gonna be no solution. So for those cases, if you get something like that, if this was like 3 equals 4, then there would be no solution. So no solution. No solution. Okay, that's just a little quick point to put in there. The last thing to know is the way it looks at in graphs. If you were to graph those two things, the equations of those graphed lines, they would look something like this. If it was like 3 equals 3, that means the equation of the first line would look something like this, maybe, for example, and the equation of the second line would, for example, look something like this. It would actually be the exact same line. The same thing. There's infinitely many solutions. It doesn't matter what point you choose. They're always going to be the same point for both equations. Each point's going to work together. They actually have the same equation, just disguised a bit. Excuse me. In the realm of graphs, if they do something different, though, if there's no solution, if it was like 2 equals, actually, I'll keep that up. 3 equals 3. 3 is something like that. It keeps these lines. Now, if it was something different, if it was, say, for example, 2 equals 4, then that gives us something like this. First line gives you something looks pretty standard, like a line like that. But the second line looking thing would actually look like this. They actually go with the same slope, the same intensity. They'll never intersect, though. So they are in the equation realm, they have the same slope. There's no solution. They will never touch, they'll never intersect, they'll never intercept each other. So there'll never actually be a solution there. Okay, so that means no solution. That means all real numbers. So or infinite. This is no solution. Okay. So that's all of that. We've solved this one 3 times now. So we know the answer to this one at this point, which kind of drilled into us. X equals -2, y equals -4. Now let's go down to the next one. How many solutions does this one have? We can graph it, we can use equation, or we can use substitution. Let's just go ahead and use elimination to solve this one, because this one actually solves pretty neatly with elimination as well. So you've got 3x minus 5y equals 15, 6x minus 10y equals 30, and this one will help us see what's going on. Let's see if I multiply, to get these to be equal to each other, I'm going to multiply let's make the x's equal to each other. Let's multiply, if I multiply that 3 by 2, then that would get me 6x, or 6. And so if I multiply everything by 2, then I can get something where the x's equal to each other. So I'm going to multiply both sides by 2. So I get 2 times 3x minus 5y equals 15 times 2. All right. And so I'm going to distribute that through. It'll give me 6x minus 5y equals, oh, sorry, not, excuse me. That gives me 2 times 3x is 6x. 2 times -5y is -10y. And 15 times 2 is 30. All right. And let's see this. That's the first equation. Let's say that's this first equation right here. That's what we did there. And the second equation, let's say that's that orange one. Let's write the orange one down. That is 6x minus 10y equals 30. Interesting. So that's the orange equation. All right. So the next step is to line these up. Well, they're actually already lined up, so that's pretty convenient. And then we subtract. Okay, so we get 6x minus 10y equals 30. 6x minus 10y equals 30. This subtracts there, this subtracts there, this subtracts there. Okay, so 6x minus 6x, that is 0. We get minus 10y minus a negative 10y. So that's like minus and minus makes a plus. So that makes it minus 10y plus 10y. Well, that cancels out to be a 0. So we can say a 0 plus 0. And then 30 minus 30 is 0. So you got 0 plus 0 is 0. And we can tell already this is something really weird. 0 plus 0, that's just 0. So 0 equals 0. Interesting. We've got two numbers that equal each other. By doing elimination, this is step 1, and this was, I believe this was step 2. This is step 2 and step 3. Just by doing elimination, instead of getting an equation, we got just 0 equals 0. This tells us that because they're equal to each other, that there are infinitely many solutions, all real numbers. If we would actually graph these two equations, they would be the same equation. It would look the exact same on a graph. So the answer to this one is infinitely many solutions. All right. Let's do the next one. I think this will be the last one for this one. A plane has 360 total seats, which are divided into economy class and business class. For every 13 seats in economy class, there are 5 seats in a business class. How many seats are there in each class? I believe that's the last problem. Let's start by, let's see, this is a word problem. But it's a word problem in systems of equations and what we've been doing. So what that means, what probably is going to happen is we're going to make 2 equations and then we're going to solve those 2 equations. That's probably what we're going to be doing, because probably just and this text here, these words are just like extra stuff to make us do those things, to make us generate and figure out what those equations are. So let's see if we can figure out what these equations are. We have 360 seats, and they are economy class and business class. let's see if we can let's see if we can make an equation after that. Let's call the economy class. Let's call that E, and it's called a business class B. Let's do that. And so let's see if let's think about this. 360 seats, and there's economy class and business class, which means if you were to put the economy class together with the business class, if you were to add them together, you get 360, whatever they are. So that would mean that the economy class plus the business class, all those together should be 360 seats. Okay, cool. Now it says for every 13 seats in economy class, there are 5 seats in business class. Interesting, interesting. Okay, so that means that, what does that mean? If there are 13 seats in economy class, then that means there's going to be 5 seats in business class. Or for every 13, there are 5. So that means if we multiply the economy class by 13, if I take, well, let's see, if there are 13 seats in economy class, that means there has to be exactly 5 seats in business class. So in order to make those two things equal each other, what can I do to make sure that those things equal each other? If I want to put an equal sign on both sides, let's see, if I want to make the business class and the economy class equal each other, or maybe if I did this, if I took the economy class and I divided that by 13, and I took the business class and I divided that by 5, I would get the same number of seats. Because if I had, like, for example, 26 seats in economy class, if I had 13 seats in economy class, I'll have 5 seats in business class. And if I divide 13 by 13, I'll get 1. If I divide B by 5, if I divide business 5 by 5, I'll get 1. I'll get a true statement. Okay, so that was a bit difficult, but that's what we can do. We can multiply. We can divide both sides by their number in order to get the same thing, because that just shows how many times we multiplied the economy class and business class, how many copies of economy and business class we have. What that answer would be. Okay, so E divided by 13 equals B divided by 5. That's a tough thing to build. But once we've got that, that should really help us. Okay, now we got E divided by 13 equals B divided by 5, and E plus B equals 360 seats. Or we can kind of rewrite this as this. This looks kind of weird. Let's keep working though. E plus B equals 360, and then E divided by 13 equals B divided by 5. This would be really weird to do in an elimination for, because if we were to use elimination for this, then we have to line everything up. Step 2 would become really fancy. But we can do substitution here. Substitution might be pretty straightforward. Let's think about this. Let's try to solve one of the variables in the first one, the first equation. E plus B equals 260. So if we subtract B from both sides, we get E equals 360 minus B. Okay, so that's what B is. So that's what E is. 360 minus B. Let's see if we can plug that in to the second equation. Let's see. 360 minus B divided by 13 equals B divided by 5. All right. And let's see if we can solve for B. This might take a step or two. We've got one equation, but we can do it. We can solve this. Let's see. We should subtract. We need to get all the b's to one side of the equation, and we can do that. Let's see. They're both in fractions though, so we got to move the entire fraction together because it's all one unit. So let's see if we move the b over 5 to the other side. So minus b over 5 minus b over 5, and that gives us, let's see, 360 minus b over 13 minus b over 5 equals b. Okay, so not a b equals 0, because b over 5 minus b over 5 is 0. Okay, now what we're going to do is we need to find a common denominator. So let's see, the common denominator is the least common multiple of 13 and 5, or the greatest, yeah, so because there's no common factors among them except for 1. Okay, so let's see. That means at the bottom, we can multiply the left side by 5 over 5. 5 over 5 times 360 minus b, minus b over 5. Let's rewrite that so it's clearer. let's rewrite that as 360 minus b times 360 over b over 13. And then minus, let's see, the right side, let's do 13 over 13. Both sides are 13, so 13 times b over 13 times 5. Let's make it even clearer. Sorry, I don't want to confuse you too much here. Let's put it this way. Let's do minus b over 5 times 13 over 13 equals 0. And remember, I don't have to do anything on the right side of the equation because I'm just multiplying these things by 1, and so that's fine. So we're going to finish out this multiplication. So let's see, the denominator is, let's see, 5 times 13, which should be 65. So this is 65. And this is 65. So that means we have a common denominator, which means we can combine them together. So we get equals 0 on the right side, and we get 5 times 360 minus b minus b times 13. B times 13. And all over 65. All right. 5 times 360 minus b, that equals, let's see, that's 5 times 260. It's 5 times 3 is 15 plus 60 would be 180. So it should be 1,800 minus 5b minus b. See, b times 13 would be 13b. So that'll be 13b. So minus 13b over 65 equals 0. Let's see, 5b minus 13b, that is, perhaps this wasn't the best method. This would be minus 18b. So 1,800 minus 18b divided by 65 equals 0. Okay. So here's what we're going to do. We're going to multiply both sides by 65. 65 times 65. Let's see, these cancel out. So it gives us 1,800 minus 18b equals 0 times 65. That's just 0. Okay. And then we're going to get rid of that 1,800 because that's the next thing on the docket list. So subtract 1,800, 1,800, 1,800. That gives us, let's see, that cancels out. So it gives us minus 18b equals minus 1,800. Okay, so this might actually come out pretty cleanly. That's convenient. Then we're finally going to divide the minus 18 on both sides because it's 18 times b, so divide by minus 18, and we'll get, because it's not just like it's just minus 18. We're not just adding 18 to a minus 18. It's minus 18 times b. What is actually happening to b? It's being multiplied. So we need to do division to get rid of it. So these two cancel out. 1,800 divided by 18, or a minus 1,800 divided by minus 18 is 100. So b equals 100. Great. So b is 100. Now we can find E. The business class is 100. And we know that economy, so in order to find economy, we can use one of the previous equations. E over 13 equals b over 5, or E plus b equals 360. I recommend you use the simpler one that doesn't involve a lot of fractions. So we'll say, we know that b equals 100. So let's plug in b, 100 for b, into the first equation. E plus 100 equals 360. Cool. Because b is 100. It's the same thing, equal sign. All right. Subtract 100 from both sides to solve for BE. We get E, finally, over all this is 260. So that means, finally, there are 100 in business class, and there are 260 in economy class. And that is it. We're done. Thank you for sitting through all this. I hope you took some breaks in all of this. That was a lot of work. I hope you did. If you have any more questions, though, if you have anything that's really not making sense, or I hope you didn't even watch this whole video. I hope you just watched like the parts that were helpful to you, and you're able to skip through and just see what you need to see. But if there's anything else you need to learn, or if there's anything else you'd like to see or check out, if you want me to walk through problems with you, just let me know. I'm here to help you as best I can. So just let me know what I can do to help you get this down, and I will see you next time. Yeah, thank you for all you're doing. Thank you for hard work.